Hello, this is Greg Smith, and I am a hydrologist with the Colorado Basin River Forecast Center. And I am recording the webinar that was presented on May 7th. This is the May water supply briefing. And this presentation will go over the weather that occurred in April, discuss a little bit the winter of 2015 and the weather pattern that we all went through, current conditions that are driving the latest water supply forecasts, and then we'll take a look at the May water supply forecast summary, as well as the future weather outlook. The presentation and this recording are listed on the websites at the bottom of this slide. So taking a look at April, April actually saw a good change in the weather pattern from what occurred in March. March was very dry and very warm across the Intermountain West. In April, we evolved to a weather pattern that was much more active and progressive. There's a couple of slides here that kind of show a little bit of what occurred in April. The flow was a lot more out of the west and northwest. We had large low-pressure systems moving through. On April 9th, it kind of shows a system that was exiting eastern Colorado. And then on April 18th, another system had moved through, a very large system, actually brought quite a bit of rain, some high elevation snow, and a lot of wind through the area. And the slide on April 18th shows a storm still churning over central Colorado. This storm also did bring quite a bit of dust into the area, and there were questions during the webinar about whether dust affected the snowpack conditions, how that might affect the runoff. Our feeling is it's not really going to affect it this much. It came late in the season, and the snowpack it was fairly depleted at this point in time. So I think the dust effects are going to be very minimal this year. The system continued, or the weather pattern continued to stay active. We ended up with a very moist air mass that moved into the area from late April into early May. We saw quite a bit of thunderstorm activity, quite a bit of heavy rainfall activity in various places. May 4th and May 6th satellite images are shown here, where you can see kind of widespread shower and thunderstorm activity over the area. If we take a look at the monthly precipitation in April on the left side, there actually were a few areas where above average precipitation occurred. You can see these are mostly limited to the lower elevation areas. The higher elevation areas in the upper Green River Basin, extending down into the Colorado River Basin, Colorado River headwaters, the Gunnison Basin, and the San Juan Basin were all quite a bit below average again. And the result we'll see soon is that there was a drop in the forecast because of this. The Great Basin again was dry, except again for some of the valley locations actually did okay. April is typically a really wet month, especially up in northern areas, northern valley areas. So you kind of need a lot of storminess, a lot of precipitation just to reach average. The seasonal precipitation on the right-hand side, October through April, this map hasn't changed a lot over the last couple of months. It shows most of the area below average in the upper Colorado River drainage or upper Colorado River Basin. Colorado River headwaters, this area above Kremling, a little bit closer to average. The snow conditions were a little bit better up here throughout the year as well. Some of the Arizona areas, a little Colorado River drainage and Gila River drainage, those areas ended up being above average seasonally due to precipitation events that occurred in January. April was finally the first month in several where we saw more seasonal temperatures. With the change in the pattern, it brought cooler temperatures so we were just slightly above or slightly below average, for a monthly average throughout this cycle, where we saw 4 consecutive months of much above average temperatures, and very widespread, particularly in February and March. We had a lot of record temperatures throughout much of the Intermountain West and the CBRC forecast area during that time. So if we take a look at the winter 2015 pattern, what is shown here on these two images are an October through March and a January through March upper atmospheric pattern. So the wind flow would be roughly parallel to these lines. The storm track would be parallel to these lines. You can see there's a large ridge of high pressure that's near the west coast over the period most of the time. And this is the reason we ended up with storms kind of being pushed out of our area and very warm temperatures, record heat most of the winter months. The opposite occurred, of course, in the eastern United States, where they had record cold and quite a bit of snow occurred. This next image here shows, how anomalous is this? We're comparing what occurred this year to the 1981 through 2010 climatology. So in these areas along the west coast and western United States, where you're kind of into the yellows and oranges and reds, these are the areas where high pressure was fairly dominant over a long period of time, and so this was quite a bit out of the ordinary for this period to see this over this long period of time. Meanwhile, in the East Coast, you can see the anomaly was quite cold, low pressure system over the area, and of course that brought all the weather back east. The result, this is a January through March ranking for temperatures, statewide temperature rankings, put together by the National Climatic Data Center. So there's a 121-year record here, and a number one would indicate it was the coldest on record, and on the other end, 121 would indicate it was the warmest on record through the January through March period. And you can see over the west in Wyoming and Utah and Arizona, those areas where we actually provide the water supply forecasts, it was the record driest. And Colorado and New Mexico not far behind. So very, very warm conditions throughout the winter months. The result of this type of pattern over the winter, record warm winter, as mentioned, it produced record low snow conditions, not only due to a lack of precipitation, but also to early melt. We actually were seeing diurnal flow conditions occurring in January at lower elevations, especially in the Great Basin, and that kind of continued throughout much of the area in February and March. We had record early meltdout at numerous sites. Many sites, especially again in the Great Basin, melted out earlier than they ever had before. Throughout the winter season, we were seeing highly variable snow conditions even within individual river basins. And this was in part due to rain falling during particular storm systems in the winter where we usually see snow. So we were seeing rain at high elevations, and we just were not building a snowpack. And so we ended up with quite a bit of variation within each basin. Above average flows occurred in March due to very warm temperatures. And then we had record low flows in some places in April. Flows did settle out a little bit because temperatures cooled off and were closer to seasonal averages. But a big part of that was due to the fact that we simply melted out the snow in March. So what typically comes off in April, the snow wasn't there. This ended up resulting in record low April through July volume forecasts for some areas. Again, most of these are in the Great Basin, particularly up in northern Utah. And then when you're not getting that much runoff due to snowmelt, rain events tend to play a larger role in the magnitude as well as the timing of the spring peak. We just went through a recent storm event in over the west, and particularly in the lower Gunnison River Basin, where peak flows on the North Fork of the Gunnison and a few of the other tributaries in that area reached levels higher than what we were expecting, but the vast majority of that runoff was really due to rainfall and not snowmelt. This next slide is kind of a look at the current snow conditions, where we have many sites have actually melted out. The lowest indicator here in the red is less than 25% of median. This is as of May 5th. And that doesn't mean there's snow there. It's just that lower than 25% is the bottom category here. So many of these have actually melted out that are in the red. Those were areas where the snow remains in orange and yellow and blue. Many of those orange and yellow sites are in the bottom 5 of record. And the records tend to be 30 to 37 years long for these snowtail sites. So snow is very limited, and it's limited to the higher elevations. Where we do have snow outside of the upper Colorado River headwaters, where we actually have some sites that are near to slightly above average. And also in the Green River above Flaming Gorge, there's a couple sites near average. The rest of the sites are very, very low. And once you get away from these sites where snow is average, it tends to drop off fairly rapidly. This is a look at the modeled snowpack conditions. So this is actually out of the forecast model that we use. And it kind of shows the same thing. It tends to follow along really close with what the SNOTEL measuring sites are showing. The Colorado River headwaters, once again, areas that are below average, but it's still the better conditions are out near the Blue River and some of the tributaries nearby in the Colorado River headwaters. Once you start moving into the other areas, though, you can see we're way below average for the time of year everywhere. So it's and in many places there's just not a lot of snow left. So really dismal snowpack conditions. This is a handful of the basin snow groups that we reviewed, and what you see here are the averages in the blue and the median and the purple throughout the season. The green is this year, 2015. The red is 2014. So we put together a few different snow groups to look at just for comparative purposes. We can see how much difference we were in the upper green compared to last season. We missed the peak by several inches, what we typically peak at, and the snow came off a lot earlier. You can see where we started melting snow here in March, and typically it doesn't really start occurring until about mid-April. So, and that's really the trend that you're going to see throughout most of the basins that we look at. For a couple of these sites, we also put in other low snow years. So in the Yampa, there's 2012 and 2002 posted, and we can see that the snow this year was very close to those years. So looking at, it kind of gives us an analog. We can look at analog years and look at the runoff and maybe make some comparisons there as well. But once again, we have conditions where we're following a 2002 meltdown now, but the peak really never got higher than either of those other two low years in the Yampa. One of the better areas, again, the Blue River, you kind of saw on the snow model graph where we had some near to above average snow. Also showing up in the SNOTEL sites. So the group for the Blue River at Dillon, a shining star, in this sea of bad news here where we have snow water equivalents that are near or slightly above average. The Colorado River main stem, though, as I mentioned, once you kind of get away from these headwater areas and start dropping further down the basin, conditions worsen quite a bit. And you can see that here in the upper Colorado main stem group where, again, things kind of flatlined after late February and then an early melt. A couple more to show. The Blue Mesa group, where we saw an increase here at the end of February, and then things leveled out and slowly started dropping off. And we saw a larger increase in the San Juan River Basin as well as the Virgin River Basin as the storm system in late February and early March moved through the area. And it really did, it was very beneficial, even though the forecasts are very low right now. The concern is if we would not have seen this storm system come through at that time, our snow trace would probably be at the lowest on record or very close to it. We definitely would be following the lowest or be at the lowest in the Virgin River group. So that was a little bit of a lifesaver to keep us out of the basement, but conditions are still not very good. And then in the Six Creeks headwaters, these are the Six Creeks basins east of Salt Lake City. Pretty much looking like this might be the lowest on record. The April observed flows are shown in this map. Again, these are very provisional. Some may change as the USGS gets out and verifies the measurements. But we can see how the flows are distributed throughout the upper Colorado River Basin and the Great Basin. Some above average flows occurred in April in the upper Colorado River drainage again. Near average in a lot of other areas, but then there's quite a few areas with much below average. A lot of this simply due to the fact that the snow melted out in March and there's not much snow to begin with. The temperatures, again, near seasonal normals. A few areas that are a little bit further above average were affected by rain events that occurred in April. So some of these just were in the right place as far as where the storms moved through, and the observations in April came in okay. Good to point out in some of these areas the April volumes are typically kind of small anyway, so it just takes a little bit more than what they normally get to see a percent of average up around 140 or 150%. And then as you move into the Great Basin, conditions in April were really poor. The runoff that was recorded in some of the Six Creeks drainages east of Salt Lake City were actually near the lowest on record. This next slide shows the April 1st water supply forecast, and we can see that there's a lot of reds and orange colors in there, so very, very much below average. In the Great Basin, we actually have some forecasts that are for the lowest record on record, including Little Cottonwood, for example, 18,000 acre-feet coming out of Little Cottonwood. But you can see throughout this area, I mean, nothing's really very good outside of those tributaries in the upper Colorado River main stem where we're expecting some near average runoff. But as we move further downstream, conditions dry out very quickly. And then this next slide shows the difference between the May 1st water supply forecast and the one issued on April 1st. And so pretty much most areas have decreased. Those areas that are in the blues where there was a little bit of an increase, that was due to the April observation coming in better than anticipated, again due to the rainfall events that occurred. Some of the storm systems moved through, for instance, the southern slopes of the Uintas, especially the lower elevation drainages on the east end, were favored by the way that system moved through, and the rain event was the rains were pretty good. So the April volumes came in a little bit higher. So the April-July volumes ended up going up slightly. But elsewhere, pretty widespread drops were the rule, most of them greater than 10%. We see an 80,000 acre-feet drop at Flaming Gorge, 240,000 drop at Cameo, and a 750,000 acre-feet drop at Lake Powell. These are some of the evolution plots, and I put a few more of them up this month simply because this is our last water supply briefing for the season. And what we have here is an example of the model guidance showing up. The blue line in the middle is the 50% exceedance probability. So this is the raw model guidance that we get that's run out each day. We can see a little bump here at the end due to the recent storm event. And then the official forecasts at the first of the month are in the red. And the range is the 10 and 90. So the 10%, 90% exceedance, and the 50% exceedance are all plotted on here. Once we get past April 1st, we start including observations. If you remember how this model works, it only works from the current day forward. So if we're still going to show you a full April-July period, then we have to add in the April observations or the observations up to that date. So it's a combination of today on through the end of July and the observations from April 1st to now. And basically they're all going to look quite similar. They show this really large decrease that started in March, and maybe it's leveled out a little bit lately because we're typically beyond our snow accumulation season at this part of the season. But March was a dramatic month where we saw significant decreases, and those continued in through at least mid-May. This is an example of the Dolores at McPhee forecast. You'll notice on this that the actual forecast that we went with is a little bit below model guidance. There may be various reasons that we don't follow the model exactly. There's a lot of great information from the model, but we also look at analog years. We'll look at similar years with the snowpack. We'll look at how the model has been performing over the past couple of months, and if it's running a little hot, if it's bringing in or suggesting forecast volumes that are a little higher than what's observed, that may be a flag to us that perhaps it's not got a great handle on the mid-elevation snow. Maybe it's got a little bit too much in it. We have statistical procedures that we also look at. We look at what's going on upstream and how that historically relates to the points downstream. So we have these routings that we can use. So we don't just blindly take model guidance. We try and stay fairly close to it, but in some cases we going through the analysis process, we do the legwork and try and come up with a little bit better forecast. We also take into consideration the fact that in the San Juan and the Dolores River Basin, we've really seen some fairly dry seasons, springs the last few years, and so it's hard to say whether we're in a long-term trend of that or not, but that's something we try and take into account as well. The Blue River at Dillon is shown here. Again, this is one of the few that is actually above average. The model's kind of been bouncing around near to above lately, but not the really big drop off because we had the good snow conditions early in the year here. And then the Weber River near Oakley in the Great Basin of northern Utah, you can see that the model guidance is starting to approach the historical minimum. So we're getting into very, very low territory in this area. And then finally, the big integrator, Lake Powell. This is just showing how the forecast has evolved throughout the season. Never really did bounce back at all, and we started below average at the very onset back in January. So taking just a look at the recent weather, and this is the storm system that moved through the first part of May. So this is the precipitation as a percent of average for the first few days of May. So this will definitely change as we add more days to this. But I think what it shows now is just more than anything where the distribution of the heaviest precipitation has been for the first part of the month, moving up through Arizona and then getting into Colorado and parts of northern Utah. So in these areas, at least a pretty good start to the month. But as you move further north, things were quite a bit drier. As you get into the Upper Green River and parts of the northern Great Basin, not as impressive. But again, these will change quite a bit, but it kind of gives an idea of where the precipitation has fallen the first part of May. Current weather, this was as of May 7th. Large low pressure system out west off near Northern California, poised to move through the forecast area through the weekend here, through the 8th, 9th, 10th, and bring considerable rain and some high elevation snow to the area. So another system that's going to be beneficial as far as keeping the water use down and maybe adding a little bit of to the volumes, but we'll have to see how much this actually brings. But the system is moving fairly fast. The next slides here are actually what the weather model, the meteorological models suggest will happen. The storm system by Saturday is kind of over northern Arizona, southern Utah. That's where the center is, and the precipitation distribution in the shaded colors, the blue, the greens, and the purples here. And so this kind of shows the progression of the system, and then by Monday it's moved off into the plains. So models are just saying it's not going to stick around long, so that may limit some of the precipitation, but it does look like it should be a good precip producer throughout much of the area for the next 2 or 3 days. And then once we get into further downstream, looking at Saturday, middle part of May, on May 16th, looking at 2 different forecast models here, the EC model, and this on the right actually should say the GFS, not the FGS. But there's a couple different solutions. We have low pressure systems off the west coast, and whether they end up dropping south, which is what the EC model suggests, and following a similar path to this storm system that's coming up over the next couple days, or it stays to the northwest and still brings in some activity. They both suggest an active pattern continuing. So it looks like we're still in a somewhat wet pattern. How much we get once we get beyond this weekend into next weekend is still a little bit up in the air. The confidence is not great, but we are still in somewhat of an unsettled pattern through the middle of May. The forecast precipitation for the next May 7th through May 14th is shown here. Significant precipitation in Colorado, especially. I think most of this is going to be east of the Continental Divide, but there should be some bleed over into the Yampa, maybe the Colorado River headwaters and the Gunnison, showing some amounts upwards to possibly a couple of inches there. And then widespread precipitation over the Great Basin as well, all the way into southern Utah. The higher amounts are going to be in the northern part of the state and further up into the Upper Green River of Wyoming. When we get into the long-term weather, we're always looking to see if there's some kind of climate signature or something that's going to maybe give us any kind of insight what might be coming. And we're back to the El Nino situation. We are under a weak El Nino. There's about a 70% chance this will continue through the summer months, and then around a 60% chance that it will actually continue through the fall and into the winter months. So a weak El Nino, it tends to correlate with a little bit better precipitation chances in Arizona, maybe at times stretching up into extreme southern Utah, extreme southern Colorado, the San Juan Basin. Once you get north of there, it doesn't really correlate all that well. So, but it does suggest that maybe we will see a more active southern branch of the jet stream as we enter the winter season, the fall and winter season next year. So I pulled up the Climate Prediction Center long-term precipitation graphics, and once again, these are for 3-month periods showing where the chances are, the better chances are for above average precipitation. Doesn't say how far above average, but just above average precipitation and below average precipitation. And on the top 3 panels, when we look at the summer months, these are dynamical models, not necessarily focusing on the El Nino pattern. These are suggesting maybe a little bit more of an active monsoon season. If you recall, we had a fairly active monsoon season last year, and these models also forecast that fairly well. That doesn't say they're going to do well this year. It's a really good, tough handle to get be able to forecast the monsoon. But there are models right now, though, suggesting that the summer months may be a little bit above average as far as the precipitation, or at least a better chance for above average precipitation over much of our forecast area. As we get down into the winter months, fall and winter months, looking at the lower right-hand panel, that's very much an El Nino pattern. That's very much an El Nino signature. So they're looking for El Nino to have to be basically, I guess, the large player for the winter months, and that's where we see the above average precipitation over the southern tier of the country, and then below average up in the northwest. Temperature-wise, kind of going with what we've seen with above average temperatures, kind of continuing throughout, at least in the west coast, and stretching a little bit into the Great Basin and Upper Green River Basin through the summer months. So there's a tendency, or at least a higher probability, for above average in that area. By the time we get into the late fall, that signature kind of disappears a little bit. We're kind of in an equal chances area. And then very much the El Nino pattern. Once again, we get into the winter months with above average temperatures in the northern part of the country and below average over the southern part of the country. Peak flows are updated. They're on our webpage. So I'm going to skip this slide over, but I think the highlight I want to put on here is you need to be looking at the daily forecast. We indicated to folks in the webinar that go to the CBRFC webpage and look at the daily forecast, since many areas are starting to get closer to that peak. Those will fluctuate day to day based on temperature inputs and observed precipitation, as well as forecast precipitation. So I would definitely, if I'm focusing on an area, look at the daily forecast at this point. A little bit of CBRFC and NOAA news. The CBRFC will hold a stakeholder meeting probably the week of October 19th. That's starting to look like the favored week. Typically, we spend a day or two. We go a lot over our forecasts, processes, the models. It's a great time for interaction on how things work. We would like to focus a little more on verification this year and what we're doing with verification, and discuss how well we do with some of the forecasts. So that's going to play a large role, and more details will come out shortly. The Weather Service also has a ribbon cutting scheduled here during the month of May for the new National Water Center, which is kind of a state-of-the-art building out in Tuscaloosa, Alabama. It's really getting a lot of play right now, as the goal of this building is for it to become a collaborative national center to support the Weather Service water mission. There's a lot more going to come out of this, but we actually will be coordinating or sharing the building with other agencies, including the USGS, in a hope that the communication and the knowledge sharing will reach levels that will really benefit the entire water mission of the Weather Service. So that's something that's going on this month. Again, we are on both Facebook and on Twitter. And then we did pause for questions, and I tried to answer them during this webinar. The suggestions and feedback are welcome for any of you to go ahead and get a hold of us. You can get a hold of me, or you can get a hold of really any of the forecasters, and their information is listed here for what you would like presented in these webinars. And we certainly appreciate the feedback, the comments, and the support. That's the May Water Supply webinar. Thank you for listening.